Hey Year 1005 mathematicians, Mr. Herman here. And this video is going to be looking at how to draw a histogram and the difference between histograms and column graphs or bar charts. There are different names, and we do use different types of graphical representations dependent on the data set that we have. So I'll be looking at 3 different examples, and I will show you the 3 different ways that we can represent this data. The first one here is a question, what is your favorite color? This was a question that was asked, a random question, and the results, the frequency has been given here. The results for blue, brown, green, and all the different colors are represented here. I didn't know if tan was a color, kind of ran out of color ideas, so I just put tan. But you notice that these the frequency or the numbers, they're kind of just in random order. Okay, this type of data that has been provided, even though that we know the frequency amount, if I were to ask the question, what is your favorite color, as we can see here, what is your favorite color, they're going to give me a response that is a category. So in this case, this information here is categorical. Okay, it is categorical data, not numerical, categorical. And because when I was saying in the previous video, if it's a categorical data, generally the question will start with, what is your favorite? Okay, there's a preference of some sort. So if we were to represent this in a some type of graph, we would use what's called a bar chart. There's also another term for this. It's either bar chart or there is a column chart or column graph. Okay, different names for them per se. What you will do is you will draw your x-axis or a horizontal line, and you draw your y-axis, which is a vertical line. And on the bottom here, this is where all your different colors will go. So we will have blue, brown, green, pink, okay, I have enough green here, red, yellow, orange, purple, I think I just have enough, and tan. Okay, and on the left hand side will be the frequency or the amount that is represented from each category. The best bet is to look at the highest number, which is red. Red here in this case has 0 as a popular number, so maybe I can scale this up to say 10, or maybe let's go 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, and I'll put these numbers just in a different color. 1, 2, 3, 4, 5, 6, 7, 8. Now this seems pretty simple. You just look at blue. We have 1, and we're going to draw 1 for blue. You know what? I'm actually going to choose the color blue, so I can keep it consistent. Because we are dealing with numbers. Oops. Color blue. There we go. And we'll go blue, and we'll color it in like that. Okay. Next color is brown. Now I've just made a boo-boo. Let's go backwards. Blue is 1, so I'm going to represent it to 1. I kind of did like 1.7 something. And paying attention. There we go. So because blue is 1, we're going to draw the bar up to 1. The next one is brown. Now this is one of the important characteristics for a bar chart, and more specifically for categorical data. When we're dealing with categorical data and we put this in a bar chart, when we do the next color of brown, there we go, you will notice that I'll go up to 4, which is there, and I'll color it in. The biggest characteristics, one of the biggest characteristics, is that I've purposely left a space between blue and brown. When we're dealing with categorical data and we pop it into a bar chart, we always leave spaces. When it comes to numerical, we don't, but we always leave spaces for categorical data. This is a big feature, if not one of the biggest features for bar charts. And we'll just keep going along, just making sure that when I plump this down, that I leave a gap in between these categories. I'm going to pause the video, I'm going to do this myself, and then I'll meet you in the next question. And with the magic of video editing, voila, there it is. Now, a few other key features to register to this question. You notice that yellow has 0. It seems counterintuitive to put yellow as an option there if the are 0, but you can consider this as maybe the question that was proposed, what is your favorite color? There was a set list that was given, including the color 0, and nobody chose 0 as an option. 0 as an option, chose yellow as an option. That's why there's a 0 there. So this is why we still include this information there, because obviously it is the least popular color. If it was just a random question that was given, what is your favorite color, and there were no choices provided, they can just choose any color randomly, then their list will pop up there, and obviously anything that has to do with the 0 won't be represented because no options were provided for them. But in this case, yellow was an option provided, so we have to put that information there that there was nothing for yellow. Second thing you also want to make sure is that on the side, we're going to add 3 different features. The first one is on the side, we're just going to put frequency or count. On the bottom, we're going to put color. Okay, these are called labels. You will always need to put labels, regardless of whether you do a bar chart or a histogram. You will always need to put labels. And the third one is we need to have a title, and the title in this case is favorite color. It doesn't need to be the actual question itself, what is your favorite color, but just a condensed version or a statement based on that question, in this case favorite color. And this is a bar chart representing this information here. Things get a little bit different then when we look at the next question: how many siblings do you have in your family? Now, this type of question is not actually considered categorical. We're now dealing with numerical data. And the reason why it's numerical is because when this question was proposed to a certain population, the answer that they were going to provide will be in the form of a number. For instance, how many siblings do you have in your family? The amount of people that said 0 were 3. There were 3 people that answered 0. Then for the amount of 1 sibling in the family, 5 people answered that. For 2 siblings in the family, 8 people, and it seems like the most popular answer that. And this goes on. You notice that there is a 6+, so 6 onwards, so that can include 7 or 8. We don't exactly know, but we just know that 1 person chose that. Maybe we just stopped at 6+ because the relevant information before that was more important for this specific survey. So numerical data, when we deal with numerical data, we now head into the land of histograms. And histograms are pretty much like bar charts over here. However, the answers provided won't be categories in the bottom, but they'll actually be numbers. There'll be numbers. So again, we're going to have X and Y. And with this histogram, we're going to look at the amount of different categories: 0, 1, 2, 3, 4, 5, and 6. Now, before we get into this numerical data, to be specific, this is numerical discrete. This is discrete data. And discrete or discrete data is countable numbers. What do I mean by countable numbers? So when I was talking in the other video, countable numbers, you cannot provide me with a decimal or fraction answer when I were to ask this question: how many siblings do you have in your family? Discrediting the answer of, yeah, what happens if I have a half brother? Well, they're still a whole person. So you, depending on the context of the question, maybe they're just talking about full siblings or including half step brothers and sisters. You'll still count them. They're still countable. Okay. And because this is countable numbers and it's non-decimal or non-fractional, it's not a measurement of some sort, this is discrete data. And discrete data have a specific way of drawing the histograms in comparison to continuous data, which is in the next example. For now, we're going to look at the different options, and this varies from 0 to 6. So my 0 doesn't necessarily start here. Because this is discrete, I'm going to move away a little bit from the middle, from the intersection here. It's my starting point. And we're going to put the number 0 here. I'm going to leave a bit of space, and I'm going to put the number 1, and this keeps going, 2, 3. Now, obviously, you would use a ruler to make sure that this is ruled up accurately. 5. Plus, I'm just freehanding it purely for demonstration purposes. Now, these are the different categories. Even it's not categorical data, but these are the different answers that are provided from here. On the side will be our frequency. You look at your highest amount, which is 8. So maybe we'll go up to 10 or 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll go up to 10. Again, just for demonstration purposes. It's good to just maybe go up to the nearest 10 or a nice number that is above the highest one. You don't want to go lower than that, or else your bar charts or your bars will go beyond the actual graph itself. Okay, so 10 is a perfect number. You don't want to go all the way up to 100, because then this would be a very squished, scaled histogram. So 8, I'm just going to go up to 10. Okay. Now, next thing you want to do is you are going to, because we're dealing specifically with discrete data, the frequency is 3 for this one. So our 3 is going to look like this. Okay, so we've hit 3, and we're drawing our bar specifically of either side of these lines here and here, on the side of 0. Okay, because 0 is the only, I guess, set category, numerical category that lies within here. So we're going to point it here. Okay, for 3. The next one, the amount for 1, our frequency is going to be 5. When we deal with histograms, there will be no spaces. No spaces. Okay, there are no spaces between these bars. So when we do our 5, we just start from the start of this end of this bar here, and we go up to 5, go across, and down there. And then this one is 5. I'll alternate the colors. You can see the difference there, and that there is the 5. Next one we have is 8. So this 2, which seems to be the most popular answer, 8, or what's considered the modal answer, because it's the most common. This will be 8, 8 being the frequency. Okay, I'm going to finish off the rest. Power of software editing. I'll be right back. Alright, here is the histogram. Now again, we need a few things on the side here. We need the frequency. So you would ideally have a bit of space here to write frequency. Alternatively, you can write frequency on the side. I'm not going to turn my laptop around to write this. So frequency tends to be the main title on this left-hand side. The bottom, we're talking about sibling sibling amount. Because these are the different categories, numerical categories. 0, 1, 2, 3, 4, 5, and 6 plus for siblings. And then the question, or the title, so those are the labels. The title could be siblings within family. Okay. And this is our discrete numerical data histogram. We're now going to look at continuous numerical data for the next example, which is this one here. So the question is, what is your arm span length? Now, the information provided looks a little bit different because you'll notice that there's this little dash here. Now, some textbooks, some questions will have this information displayed differently. There's different ways to talk about this, but essentially the provided answers that can be given, you can either have it in the form of a decimal, okay, or even a fraction. So this right here, it is numerical data. It's numerical, but it's continuous data. So this means I can just provide a decimal or fraction answer. And when we deal with continuous data, again, we are going to draw a histogram. Okay, and with histograms, there's going to be no spaces. But there's one really tiny difference between discrete histograms and continuous data histograms. With this here, 9 people have provided the answer in the form of a centimeter, the arm span length. 9 people chose in between 150 to 160, but didn't give, it doesn't lie, 160, sorry, doesn't lie within here, okay? 160, if 160 centimeters was also provided as an answer, it will be put into this category here, or this length interval here. And this is what that little dash means, because I could have written 160 like this, between 150 to 160, and then between 160 to 170, and then 170 to 180, and what. But then what happens if someone said, oh, okay, my arm span is 170? Which frequency amount would you put it in? This one or this one? Because both of them have 170, don't they? So this is what's called an overlap. And when we talk about histograms and given this information, when we draw this frequency table, we can't have any overlaps happening. This is a big no-no. So to compensate for this, we put 150 and then a dash. And then a lot of students will ask this question, well then how come we can't put 150 dash maybe 159.99? And well, yeah, this is a valid answer if the question that was provided said, what is your arm span to 2 decimal places? But that wasn't elaborated within this question, because someone could give me the answer 159.998, which doesn't lie within this interval, but then also doesn't lie within this interval as well, and it's within a non-interval chunk. So again, to compensate for this, we just put 150 and then a dash. So that means 150 all the way to 160, but we don't include 160 within this interval. That's for the next one. And then again 160 all the way to 170, but not including 170, because that's for the next one. And that just keeps going on and on and on. Here, this is 190 onwards. It's technically past 190. Here you can put a stop if you wish, and I'm going to put 190 to 200. Okay. Now there are different ways of writing these length interval chunks, which includes less than and equals to signs. Don't have to worry about that for now. What I care about more is displaying this information via a histogram. So again, we're going to have a 2 interval lengths, I'm just going to blur this side over here during my editing because I've got somebody asking me questions, so apologies. What we are going to do, I'm just going to scroll this down a little bit. This length interval chunks, our first length starts at 150. Okay, so that means in between 150 and 160, 9 people provided answers. You could have had 152.6, 158.33. There are 9 different solutions, not solutions, but 9 different people provided answers within that interval. Because 150 is the lowest number, we find it pointless if we start with 0 and then go to 10 and then go to 20 and then go to 30 and 40, etc., all the way to 150, because then there's going to be this massive chunk of information that's going to be pretty much almost irrelevant to the histogram itself. So what we do as mathematicians is we've created this symbol that looks like that. Alright, so we're going to put that in there like this, and that just means we're skipping from 0 all the way to whatever the first number of interest is. In this case, it is 150. Okay, so we're going to go all the way, and we're going to start here at 150. And then the next number is going to go all the way to 160. And we're going to do this all the way to 170, all the way to 180, all the way to 190, and all the way to 200. Alright, so we skipped a few, we've skipped quite a bit, gone from 150 to 160. They are in chunks of 10 centimeters. And the frequency, the highest amount is 15. So maybe we can do chunks of 5, 10, 15. So let's just get rid of this here, so it doesn't interfere with what we're trying to do. And we'll put this as chunks of 5 here, 10, and 15. Alrighty, if you want, you can go ahead and go 4, 3, 2, 1. If you find that easier, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so now this is one of the main differences between continuous data for histograms and discrete data. You'll notice that I'm now not going to draw my bar in the middle of the first number, or any number that is. I'm actually drawing my bar in between the interval chunk of 150 and 160, and for each one of them consequently, because this is provided as a interval. So between 150 to 160, we're not including 160, we know that 9 of these people had an arm span in between 150 to 160 centimeters. And that is going to be our first bar for the histogram. And then again, histograms do not have any spaces. So the next chunk from 160 to 170 is going to be 12. So we're going to continue from this line, 10, 11, 12, and go across to the next one and color that in. Okay, again, no spaces, but if you can comparatively see the difference between that and this one here, these numbers are in the middle because they're dealing with discrete. These numbers here are chunked at the end, the start and the end of the bar, because they're continuous. Alright, software editing, do your magic. Okie dokie. Now we have got our arm span length histogram, no spaces, chunks via intervals, labels, frequency, armband, and a title. This is how you create histograms. 25 and nearly 26-minute video. Again, quite a long video for such simple questions and low amount of questions, but trust me, this will help you out with the later questions going on and ultimately your assessment when it comes to the end of this topic. Hopefully this helps you out. Stay safe, guys, and I will see you in the next video. Ta-ta.